Yo, Code Blue here. This is the second video of our C++ playlist. Now, today we're going to be learning literals or primitives. And a primitive in a language is a variable that can store information. Now, this may seem very obvious or strange, depending on who you are. But let's think about what a program is. A program is a collection of operations, and those operations are operating on memory. So we are storing memory, so it doesn't matter what that memory is, in the computer, and then we're doing stuff with it. From games to software for companies, it's all the same thing. It's information that's being changed. So, to store information on the computer, to store it in the CPU, we're going to use these primitives. Now, there are several primitives in the C++ language, but let's start with the integer. Now, if you know from math class what an integer is, it is a number that is whole, meaning there are no decimal or fractions, and it can be negative, it can be 0, and it can be positive. So an integer, we're going to name it now. It's going to be x, although you can name it a full word. So xxx equals 666.666. Now we can write the semicolon. After every command that you do, you must write a semicolon. It means that you have finished your operation. So this line, what you have done is if you've reserved one integer of space, which is amount of bytes, to keep the number 666. So there is space on the computer that you're using up for this program. And that's all the memory that you're using up for yourself. 666. Now, the math with primitives is exactly like it is with in normal life, except the equal sign doesn't mean the same thing. What we are doing here is we're basically putting 666 into a box. This isn't code. I am simply showing you what we are doing, and we are putting it into a box. But that does not mean that xxx will equal 666. It means that xxx is now 666. Okay. Now we're going to make an integer named yyy, and we're going to set it to 333. So 333 is yy, and xxx is 666. Now, after you have created the variable called instantiation, you do not have to write the integer again. Now you can simply use the variable, and it will remember that it is an integer. So, let's say that we wanted to add 666 plus 333. We would say xxx, we would say int sum equals xxx plus yyy, semicolon. We have added the numbers, they've become 999, and we've put that into the sum. Now, from the previous tutorial, if you remember how to print things out, you write cout, arrow, arrow, sum, arrow, arrow, and L. You can print out numbers. And then we return 0, because this program returns an integer. We will talk later about what this means, but right now we are simply printing out a number. So let's compile it, press the gear, and let's run. then we get 999. Now, integers allow us to do a lot, but they don't allow us to do everything. Because what if we needed to use pi? What if we needed to use more complicated maths that include decimals and include fractions? We would need to use a different type of variable. That variable is called a double. A double is a very precise decimal. It is not infinitely precise, so we can't store pi, but it can store something that's pretty well. You won't need something that's more accurate than a double, and if you do, you will make it yourself. So a double is done the same way as an integer. Let's say double pi equals 3.14 semicolon. Now, once we make pi, what this means is this is put into pi, as we remember. But if I were to add, say, pi plus equals xxx plus pi, semicolon, we are taking 3.14 and adding it to 666. So would the answer be an integer or would it be a double? Well, one of the properties of doubles is that any integer you add to it it still is a double. And the property with integers is once you add a double to it, it becomes a double. So let's compile. Let's take this, put it down here, and print pi. So we get 669.14. However, if I set it to xxx, so we've added 666 plus 3.14, what do you think will happen? Well, when I try to compile it, and when I try to run it, the answer... Oh, oops. Forgot to print out the right thing. When we compile it, and then when we run it, the answer is 669. Where did it go? Where did 0.14 go? What happens is the double holds information that the integer cannot hold. So that information is thrown away. So because it's more accurate, it can, when we give it to the integer forgets that information, or it can't even hold it, so it throws it away. Those are integers and doubles, and we will continue in the next video with floats, chars, etc. See you then.